We're going to deal with double bonds and triple bonds. Okay? In order to have an octet, some atoms will form double or triple bonds. Okay? And I might further add that this occurs when there are too few electrons to make enough bonds. All right? So in a double bond, what you get is 2 pairs of electrons are shared. And what would you get with a triple bond? Absolutely right. You would get 3 pairs of electrons. Okay? So let me show you how this works with well, this isn't sulfite. What is this? Sulfur trioxide, right? Because there's no charge. And then this is called hydrogen cyanide. Or, yeah, we'll just go with that for now. All right? So here we go. I'm going to put my sulfur in the middle. How many valence electrons does sulfur have? Let's see. It's in the oxygen's row. It has 6, right? Okay. So I go 1, 2, 3, 4, 5, and 6. Right? Well, here comes oxygen. How many valence electrons does oxygen have? 6, right? Oops. You know what I want to do? I want to actually just put it right there. I'm going to draw oxygen right here. First electron's going to make a bond, right? 1, 2, 3, 4, 5, 6. Okay. Here comes another oxygen with its 6. Now, I've been saying it's going to make a bond, but let's not worry about that. We're just going to make this fit. 1, 2, 3, 4, 5, 6. All right. And then the last oxygen right here. 1, 2, 3, 4, 5, and 6. Now, how's that work? Okay, this oxygen has 2, 4, 6, 8. That's good. This sulfur 2, 4, 6, 8. This oxygen 2, 4, 6, 7. This oxygen 2, 4, 6, 7. Wow, we don't have enough electrons to make everyone have an octet, right? So this is what's going to happen. And for when we practice, you're going to find out that you're usually going to have a lone electron, okay, sitting in 2 spots. So guess what they're going to do? They are going to come together. And what I'm going to do is I'm just going to do a little erasing here. I mean, it would be great if I could draw some arrows and go, oh, hey, it's going to go here, and this one's going to go there, and this one's going to go there. But we're not going to really worry about the mechanisms. So I'm just going to, let's see, I'm going to redraw it. Actually, that'll be better. I'm going to put sulfur here, okay? And I'm going to put a double bond in between, try this again. I'm going to put a sulfur here, and I'm going to bond it with a double bond to an oxygen. Well, all I've done is I've taken this electron, I've put it right there, and I've taken this electron and put it right there. And I'm drawing arrows just like I said I wouldn't do that, huh? And then I'm going to take these 2 electrons right here, and I'm going to put them under there. Okay? It's important not to sweat the details about this. All right? We're going to do a lab where you're going to get to play with pennies and atoms and get it to work, but for right, oops, I don't want another double bond. But we're just going to kind of finagle and make sure that we have the right number of valence electrons and make it work. Okay, now just as a quick count, we've got 4 times 6, which equals 24 electrons, right? 4 atoms with 6 valence electrons each. Well, let's count how many I have. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. All right? So this thing right here is a double bond. That is a double bond. Okay? But if you look at every element, this counts for 4 electrons. 6, 8, so that oxygen's content. Sulfur, 2, 4, 6, 8, that's content, and then these both have 8. All right, you've got to manipulate the electrons to make sure they work. You can't add or subtract electrons unless it's an ion. All right, don't panic if you're going, what in the world is this? We're going to play with it in the lab. All right, so let's do carbon. Here's carbon with 4 valence electrons, right? Here comes nitrogen. How many? 5 valence electrons. 1, 2, 3, 4, 5. Okay? And then here comes hydrogen with its 1 valence electron. All right? So look what we have. We have a slight problem. This nitrogen has 1, 2, 3, 4, 5, 6. Not good enough. This hydrogen has 2. That's good enough. This carbon, 2, 3, 4, 5, 6. Not good enough. But we have this lone electron here. We have a lone electron there. Let's just say those two are going to come together and form a bond right in there. All right? So I'm going to try and erase those without erasing the whole letter. Let's see. There we go. And then now look what I have. I have 2 lone electrons. This one right here and this one right here. Well, let's say those are come together and make a bond right there. Okay? Now, let's see if everyone's content. Carbon has 2, 4, 6, 8. Nitrogen has 2, 4, 6, 8. All right? We started with 10 valence electrons. All right? 2, 4, 6, 8, 10, and there you go. So that's a triple bond. Kind of weird. Don't worry. In the lab, you're going to play with this, and it's going to start making sense for those of you that aren't quite getting it right now. All right? So this is your introduction to Lewis dot structures. There's one more situation that pops up that I want to go over briefly, and that's called resonance. All right? Because what about O3? Here's a problem. I'm going to draw O3, which is ozone. Right? There's oxygen. Here comes another oxygen. 1, 2, 3, 4, 5, 6. Here comes another oxygen right here. 1, 2, 3, 4, 5, 6. Okay. See a problem? Well, the central oxygen is fine, right? It has 8. 2, 4, 6, 8. But the outside oxygen is 2, 4, 6, 7. They don't have enough, right? So whenever we don't have enough valence electrons to make it work, we're going to have a double bond. So I'm going to just pretend that these 2 electrons right here are going to make a double bond right in here. How's that? Okay, so I'll erase those. Okay, and so there's my structure. Now let me draw it just a little bit better, although you guys know how I draw. Yeah, I don't know if this is any better or not. Okay, so there's my representation of ozone. But here's a problem. How do I know that this double bond is not really over here? I mean, what's going on? What's to say it's not over there, right? And so this is one of the let's see, what's the best word on? This is one of the shortcomings of the Lewis dot structures. Okay? And so one of the shortcomings of the Lewis dot structures is they can't represent a bond. Well, they can't represent completely what's going on, because we know from experimental evidence that the average bond length between for this oxygen and this oxygen is about 1.5. Okay, which is less than 2, but greater than 1, right? So the Lewis dot structures can't really represent it. So what we do is we draw an arrow, a double arrow. Let me erase some of this because this is getting really, really messy. We draw a double arrow that represents all the models. Okay? So I'm going to go like this. I'm going to put the double bond right there. Okay. So this shows the double bond being over there and the double bond being over there. Okay. That's what we do to deal with what's this thing called resonance, which shows that the bond is really, and we don't want to think of it as moving, but the Lewis dot structures can't represent what's really going on. That's one of the shortcomings. So how can we represent nitrate? All right. Now, because of time, I'm just going to draw it out real fast and not go through all the deal. But basically, this is what nitrate looks like. Okay. But the question is, well, where's that double bond? Why couldn't I have drawn this double bond here or here, right? Well, in reality, it really is kind of being shared. Remember, electrons are moving around, bonds are moving around. It's a dynamic moving thing. We're drawing something in two dimensionals as just a quick piece, and really that's not what's going on. So to represent that, you got to draw all three, and I've got a picture of it here, so I don't have to try and draw it out. And so that, hopefully you can see, represent all three. Here's the double arrow, right? And then I'm putting the double bond in all three spots. And since it's a polyatomic ion, we're drawing brackets in the charge. Okay, so that's what's going on with resonance. And then I just want to give you two more points to understand about it. One, it's not like the molecules oscillating between these forms. Okay, in other words, it's not like it's going back and forth between this bond, this shape, and this shape. That's really not what's going on. Remember, we're talking about average bond lengths. We're talking about an electron, a molecular orbital that's moving. And then the other thing, and we excuse me, we draw the resonance structure because you can't really show what it looks like with one single structure. All right. So there you go, Lewis dot structure. We'll do an activity in class that'll get this hopefully make it a little clearer for you, and I'll see you soon.